Hey everybody. So this last one's going to be just on Newton's third law, and it was for every action there's an equal but opposite reaction. So I like to envision this as two people on ice skates, because then it's nice and easy, kind of almost remove friction. So I'm going to have one individual. They're on ice skates. Oh, better give them some ice skates. Pretty good, I know. And he's going to have a mass of 50 kilograms. I have another individual. He's going to be a little bit bigger. Put on my ice skates as well. And he's going to be twice as heavy. So he's going to be 100 kilograms. His mass will be twice as much. If they were to stand hand to hand and they were to push off one another with the exact same force, what would their acceleration be? So it's important to know that force is in fact a vector. So if I said that the force was in this direction, and that was, we're going to say they're both 100 newtons. So if it's going to give an equal but opposite reaction. So you could even say if this is 100 kilograms and he pushes the 50 kilogram individual with a force of 100 newtons, or we could say that the smaller individual pushed on the larger, that force is going to be equal, but in the opposite direction. So only one has to push. So if it was in a force of 100 newtons, and this is now going to create that equal but opposite force, only one person has to push. What is going to happen? How fast will each other accelerate? You can use that very, very basic force is equal to mass times acceleration. And you do this for both to see who is going to accelerate faster. And you could, it doesn't matter which way you analyze, is the larger individual pushing or is the smaller individual pushing? The force is going to be the same when only one is pushing. Okay, so we'll do quick transposing. So we're trying to figure out the acceleration. So then it's just going to be the force divided by the mass will equal the acceleration. So 100 newtons. I want to make sure I'm not running out of room there. Divided by my 50 kilograms. Is going to give me 2 meters per second squared. So we're going to do the same thing over here. The force of 100 newtons, because remember it's equal, but it's opposite. So force of 100 newtons divided by the mass. Now we have 100 kilograms. That's going to equal an acceleration of 1 meter per second squared. So when it comes to motors, what's really, really important is that if I have a motor, and on that motor, it's going to have a shaft right in the middle of it, that motor is going to exert a force, and we're going to get into that. It's called torque. So the torque of the motor will always equal the torque of the load. And the other, often you'll see this is the load is described as counter torque, and it has to be the same. So the torque of the motor will always equal the counter torque. And this is exactly where this comes from, is Newton's third law. If I decrease the counter torque, or I decrease the load, my motor doesn't produce as much torque. If I add more boxes to my conveyor belt, I increase the load, the motor will produce more torque because there is more counter torque. If there's no counter torque, so you have no motor, no load, not no motor. If you have no load on that motor, you would say, well, Jason, there's no torque produced by that motor. And I'm okay with that statement for now. We'll get into how we have to remember that the rotor always has a mass, so there will always be a little bit of torque just based on the mass of the rotor and how the construction of that. But it's not it's an okay thing to think. If I have no load, I'm not producing any torque, or a very, very small amount. So this is just, it's a really good thing that we understand the basics, and then for the motor theory, we're going to move on from here. But Newton's first 3 laws are fundamental for us understanding what a load on a motor, how that affects the motor, and what the motor is doing within it. So I hope this helps. This is going to be kind of the end of the Newton's third laws. This is as far as we'll go. There's much more information and farther depth that you could go with this. This is kind of as far as we'll take it. So I hope this has helped. See you in the next one.